Okay, first thing that we've got to consider here is the fact of going back to your domain that x cannot be equal to 0 because that would cause this function to be undefined. So we need to keep that in mind. Okay, so getting your first derivative using your quotient rule. Okay, now taking this and simplifying. Of course, this would give you 4x to the 5th. Now you need to distribute the 2x, but you also have the minus that you need to distribute. So just treat this as a negative 2x. So therefore you'd have a negative 2x to the 5th minus 2x. And that would be over x to the 4th. So now you have 2x to the 5th minus 2x divided by x to the 4th. Okay, you do have a common factor of 2x in the numerator. Okay, you can do a little bit of reducing here because this x will cancel one of these, which means this is now down to a 3rd power. All right, so when you're locating your critical numbers, finding out the values that cause your numerator to equal 0. Of course, the times 2 here you can ignore. We had talked about that earlier, and just take the x to the 4th minus 1. So you would have x to the 4th is equal to 1, so x would be equal to plus or minus 1. And then your denominator, and again, you could ignore the 3rd power, and that would just be x equals 0. So positive 1, negative 1, and then the 0. So putting these values on a number line to make your sign graph. So here's our negative 1, and then we would have the 0, and then we would have the positive 1. And you need to pick a test value for each of these intervals. Now we need to substitute each one of those into, remember, the first derivative. Of course, you're still seeing your first derivative here. So if I were to substitute in the negative 2, that's going to give me a positive on the top, a negative on the bottom, so that's going to give me an overall negative. Okay, now if I put in the negative 1/2, okay, so that's going to give me a negative on the top, and then I'd also have a negative on the bottom, so negative over negative is going to give me a positive. Okay, now substitute in the 1/2. Okay, so that's going to give me a negative on the top and a positive on the bottom, so that would be negative. And then if I were to substitute in the 2, then that's going to give me a positive. Okay, so this interval would be decreasing, increasing, decreasing, and increasing. All right, so let's write those intervals out. Okay, so we're increasing. Well, we'll just start with decreasing. That would be negative infinity to negative 1. and then I decrease also from 0 to 1. And increasing would be -1 to 0, and then from 1 to infinity. Now, as far as picking your extrema or your maxes and mins, okay, here your function is decreasing. It's negative, changing to positive, so that's making a valley. So this would have to be a min. Now, on this one, you're increasing and then decreasing, so you may be thinking about maximum, but if you remember back at the beginning, we stated that x could not be equal to 0 because that causes your function to actually be undefined. And graphically, what's happening there is you have a vertical asymptote. So you can still have your intervals of increasing and decreasing changing on either side, but you cannot have an extrema. There cannot be a max or a min here because your function is not defined at 0. There's not a point there. So just always be aware of situations like that. And then this would have to be another min. All right, so I need to locate these points. So I would have f of -1. Now remember, in this case, you're substituting back into the original function. So if you were to substitute -1 back into the original function, you're going to end up with 2. So that would be the point -1, 2. And then substitute +1 into the original function. So that's also going to give you 2. Therefore, we have the point 1, 2. And again, these are both mins. Okay, so there's that example. Okay, next one that we're going to look at. One difference that you have here is they're actually giving you an interval over which this function is defined. Because actually, if you substitute any values larger than 3 or any values that are smaller than -3 into this function, that's going to end up giving you a negative number underneath the radical, which leads to your imaginary numbers. So actually, your function is only defined for the values that are between -3 and +3. And we'll discuss what that means when we actually go to do our sine graph. It doesn't affect you doing your derivative though. What I'm going to do first though is actually rewrite this as 9 minus x squared to the 1/2 power. Okay, you're going to have to use your product rule on this. Okay, so we'll have our first function, and then you multiply that times the derivative of the second. So this would have to be 1/2 times the function to 1 less power. Then you have to apply the chain rule and take the derivative of the inside. Okay, plus second function times the derivative of the first function. Okay, one thing you could do is go ahead and say, okay, those 2's are canceled out. Okay, now what you have in common, of course, all that you have in front of the plus sign, and then you've got what you have after the plus sign. So you do have, and I left my square off right here. Make sure you go back and put your square. So you do have the 9 minus x squared that's in common. You also have a 2 that you could pull out if you chose to, or a -2 if you wanted to look at it that way. All right, so let's pull out a -2, and we're going to pull out 9 minus x squared to the -1/2. Now we had dealt with the fact of having the fractional exponents back when we first learned product rule, and it's always going to be the smaller exponent, you remember, that you actually pull out. Okay, so I'm pulling out the -2, so I am left with this x times this x, and that's going to leave me with an x squared And of course, the 9 minus x squared to the negative 1/2 is gone as well. Now, since I am pulling out a -2, I do need to change this to be a minus sign. But when you're pulling this from this, what you're always going to do is this exponent minus this exponent. So if you do 1/2 minus a -1/2, then you actually just get that left to the first power. You do need to be careful though, because I did change it to a minus. So let's put it in parentheses, and you're left with 9 minus x squared, which would just be to the first power. But I will need to distribute the minus sign. Okay, so that's going to, of course, change that to be plus, so I'll have a positive 2x squared minus 9. And then I need to move this to my denominator. Okay, so now finding the values that cause this to equal 0 and what makes it undefined. So when you set your numerator equal to 0, again, you can ignore this -2, so you can just take the 2x squared minus 9 equals 0. So therefore I have 2x squared is equal to 9. So x squared is equal to 9/2. So x would be equal to plus or minus 3 over square root 2. Now, if you wanted to rationalize that, you can, but I'm just going to leave it as it is. Okay, then setting your denominator equal to 0, and again, you can ignore the 1/2. That's not going to affect it. So 9 minus x squared. So therefore, that'd be 9 is equal to x squared, so x is equal to plus or minus 3. Okay, so when you go to do your number line, or your sign graph, well, actually, I didn't mean to put arrows here. Since you are given the interval from -3 to +3, what I should have done, instead of doing my arrows, is I'm going to put a bracket at each end, because I'm actually not going, you putting arrows mean that your graph is going to -infinity to +infinity, and it's not. It's only going from -3 to +3. So here's your -3, here's your +3, and as far as the 3 square root 2, 3 divided by square root 2 is approximately 2.1. So that would fall within this interval. Both of these numbers would fall within here. So mark this one off. So that's going to be the -3 over square root 2. And then here would be the +3 over square root 2. All right, so since this is approximately 2.1, then I could use like 2.5 for this interval. I could use 0 here and then -2.5 here. Now remember, you are substituting these into your first derivative, okay? So substituting these into my first derivative. Give me just a second to enter this in. Okay, so from the -3 to the -3 over square root 2, you'll actually get a negative value there. And then if I were to substitute in 0, that's going to give me a positive on the top, positive on the bottom. So this is going to be a plus. And then if I substitute in the 2.5 into the first derivative, then that's going to give me negative. Now remember, you're substituting these into this first derivative, okay, not back into the original just yet. All right, so what I figured out is that this section's decreasing, this section's increasing, this section's decreasing, okay? So let's identify those intervals. So increasing would be from negative 3 over square root 2 to positive 3 over square root 2. Decreasing would be from negative 3, so you're not doing negative infinity this time because your graph only goes from negative 3 to positive 3. So from negative 3 to negative 3 over square root 2, and then from 3 over square root 2 to positive 3. That would be your increasing and your decreasing, okay? Now, maxes and mins using your first derivative test. If you're decreasing and then increasing, this would have to be a min. And then if you're increasing and then decreasing, then this would have to be a max. Okay, so we have f of negative 3 over square root 2. Okay, so doing a little bit of work here. We've got to substitute this into our first derivative.